Right. Hello. Can everyone hear me? Right. Cool. So today I'll be talking about the unified. Oh, I'm Swapnil. I work at Nethermind. I am the head of innovation at Nethermind, and I'm working with EigenLayer on a unified node spec for EigenLayer AVSs, and that's what this talk is about. Before we talk about EigenLayer AVS node spec, we should touch a bit upon EigenLayer itself. And for those who don't know what EigenLayer is, I'm going to do a quick 101 on what EigenLayer is. So EigenLayer is a marketplace for robust security, where we can leverage Ethereum security for new services. How EigenLayer achieves this is by making the validators for Ethereum itself opt into additional slashing rules and follow new consensus algorithms and put up their Ethereum stake against some new service. By the way, I'm happy to take questions in the middle of the talk as well. So if you have any questions, just raise your hand. Cool. Right. So now that we know what EigenLayer is, and we know that validators are included in this dynamic, in this robust marketplace, taking a quick look into the future, we can see that there's probably the case where there's going to be many AVSs built on top, because the validators are incentivized economically to restake their Ethereum security and get more rewards with it. So economically, a validator is incentivized to run as many nodes as possible. So we can see a future where a validator might need to run 10 or even hundreds of nodes. And this is quite problematic for many reasons. One of them being that it might be a centralizing effect on validators itself. I'm not going to be touching on that topic today. That's a topic for a different discussion. What I will be talking about is the technical part of it. What does it mean for a node operator to run 10 or even hundreds of nodes, which might not conform to one spec? They might have their own unique interfaces. They might do metrics collection in some manner. They might do databases in some other manner. They might do updates in some other manner. And this is going to be very taxing for node operators. They now have to learn 10 or even hundreds of new commands. They have to keep them all in their mind. They have to figure out how metrics selection for them work. They might need to aggregate metrics across all of them into one dashboard. Setting up alerts is also another problem. So in general, node operators this also causes a centralizing effect for node operators, because now you need to be hyper-specialized and hyper-aware on how these new orchestration software might work or stuff like that. Cool. So what is our solution? Our solution is a spec, specification for node AVS software that focuses on unifying the interfaces of all operations that a node might need to do. Our solution focuses on solo stakers. We can expand this specification to institutional stakers as well, but first we want to focus on solo stakers. And it's really there to optimize the experience of the operator itself. Right. So in Ethereum, we kind of have this problem as well, but on a much smaller scale. So there's four consensus layer clients, 5 execution clients, so there's only a combination of 20 parts where you can run them in. Even though they follow the same specification for the consensus and execution, they don't follow the same specifications for the node operator experience itself. What I mean by that is they don't collect the same kind of metrics. Even if they do collect the same kind of metrics, they might name them differently. The RPC methods are standard, but also they have some unstandard RPC methods supported in all of them. And we don't want to repeat this problem in the EigenLayer ecosystem one more time. So we've caught on to the problem early, and we want to use our experience from Ethereum to define a specification that can help us standardize the experience of node operators. Right. So the first part of this specification is the packaging. In the first instance of the specification, which is meant for solo operators, we are recommending they use Docker and Docker Compose for the orchestration. We also have made up a new idea called profiles and manifest files. If you worked with the browser extensions, then the manifest file is quite similar. It specifies the version of the node software itself, but also the spec that you're following. It specifies things like hardware requirements, the plugins, and we'll get into later what plugins are. And the last bit there is profiles. Profiles are specific instances of a network for different profiles. And what I mean by that is, let's say you're running an AVS which looks quite like a blockchain, so there might be a testnet profile or a mainnet profile. And for testnet, you might want to do some other things, like you might want to have way many more peers compared to what you have for mainnet, because testnet peers might go down all the time or something like that. Right. Moving on to publishing nodes. We've chosen a style very similar to Homebrew, if you use Homebrew. It's not all the way, as in where your homebrew formula is not specified in a Turing-complete language like Ruby. We just specify it as a configuration file. And if you look up there, the first two packages on there are mainnet and girly. And in this case, they are the two profiles. So this AVS, which is unspecified name here, can run two profiles, mainnet and girly. There's folders underneath it called alerts, dashboards, and panels. And those are all the folders that have all the information related to monitoring the node itself. Then there's the Docker Compose, which specifies how the orchestration for this node should work. Then there's the profile, which specifies the environment variables, configurable environment variables, which the CLI might prompt you to fill in once you start running a node software in this specific profile. Girly has similar stuff, and at the end, you might see a checksum there. The checksum is there to verify the authenticity of the node that you download, so you can make sure that the one that you download is the correct one. One thing you might have in your mind right now is the checksum is distributed in the same network or the same manner as the node software itself. And both could be manipulated with if you break TLS or you do a man-in-the-middle attack. But we have plans of putting the checksum on Ethereum itself. So you have the most decentralized way of inheriting the checksum and checking against your node software. Right. Moving on to the advantages of having this kind of spec, we can do seamless updates because from the node operator's perspective, they can type in a command saying EigenLayer update EigenDA. And at that point, since we are running the orchestration, we know how to shut the containers down, we know how to shut the containers back up, do the database migrations, and so on and so forth. Plugins. So this is, I think, one of the most important bits of our spec. You can imagine that there are many instances of many AVSs that we can't cover all of them. So let's say there is an AVS that does data availability, but from time to time, it might require you pruning the DB. We can't capture all of these special features of all AVSs in one unified spec, because then it'd be untractable. We would have to scale with every new AVS that comes around. We need to we need to expect all their needs before they even come out. So what we've designed is a system where the AVS developers themselves can specify some utility of their software and add dynamically to their CLI. And then our CLI knows how to interact with that CLI and can smooth over the things like, then they don't have to do orchestration. Our CLI manages all the orchestration bits, and their CLI tool can manage the AVS-specific operations that they might want to do. Some of the use cases for plugins might be key management, so you might want to generate keys specific to your format. You might have a new signature scheme or something like that. Running database pruning, enabling, disabling node functionalities. So yeah, you can imagine we have similar interfaces for Ethereum nodes, and you want to capture the same experience on EigenLayer AVSs as well. The principles for the plugins that we kept in mind while designing the plugin system was that it needs to be containerized. We can't let information leak from the plugins, because that can create a vulnerability where someone downloads a plugin and messes up with the operations of the AVS, which might cause the AVS to miss attestations or even cause slashing for the node operator. Node reachability, and what I mean by that is that the CLI tool orchestrates your AVS setup, but your plugin shouldn't have to understand how the orchestration works. For it should be transparent. For now, we use Docker Compose, but in the future, we might use Kubernetes or kubectl to manage your nodes for institutional stakings or larger setups. And at that point, the plugin system should be independent of that and should not expose those details to you. So now, what are the steps required to add a plugin next to your node? What you have to do is just add the plugin in the manifest file. The CLI tool will, once you download the AVS, it will also fetch in the plugin. It will verify the checksum, and it will make sure that the plugin is the same one that you specified in your manifest file using the checksum. So this is an overview of what we do for the metric specification. We've standardized the Prometheus metrics, the HTTP API, and also the Grafana dashboards. And we are also releasing a tool for AVS developers so that they can make their own modular Grafana dashboards. So the HTTP API is quite simple. So one of the base things is that it is prefixed by the query parameter or URL/eigen. So anything under that path should be related to the HTTP API related to monitoring. And this is not the full-blown specification, but all is there for doing health checks, doing service management, and basic checks. There's a much more bigger specification for the Prometheus metrics, which covers things like rewards, slashings, and other AVS-specific things. We make sure that all the AVSs label their metrics with the AVS name in the tag itself, because let's say you have eigen_rewards for eigenDA, but you might have a similar metric for some other AVS. And we make sure that we distinguish them between those two using the AVS name itself. We also allow developers to use custom metrics. So there's a set of metrics that are required, and these are metrics about the CPU usage, RAM usage, how much network bandwidth they're using, and host machine metrics, basically. But again, we can't cover all the metrics that they might use, so we let them specify their own metrics. And in this case, we ask them not to use the eigen prefix. So the benefits of this for the ecosystem of this node spec in general are the fact that now we have a unified experience for monitoring nodes. We have easy integration to production quality tools like Prometheus and Grafana, and this is great both for node operators and developers. And this also promotes better transparency and better node development practices for the entire ecosystem. Right, so the spec is out. You can go have a look yourself. We're always looking for feedback, and there's a repo attached to it, so feel free to open an issue and reach out to us if you have any questions or suggestions. And now I'm open to questions, if there's any. I'm assuming I gave such a good talk, you now understand all of it. Cool. I think if there's no questions, then I've done my job right. Thank you.